Chapter 8 Redux. Redux has emerged as one of the clear winners in the field of flux or flux-like Libra. Rees. Redux is based on flux, and it was designed to tackle the challenge of understanding how data changes flow through your application. Redux was developed by Dan Abramov and Andrew Clark. Since creating Redux, both have been hired by Facebook to work on the React team. Andrew Clark was working on version 4 of Flumox, another Flux-based library, when he started assisting Dan with the task of completing Redux. The message on the NPM page for Flumox reads: eventually 4.x should be the last major release, but it never happened. If you want the latest features, then use Redux instead. It's really great. 1 Redux is surprisingly small, only 99 lines of code. We have mentioned that Redux is Flux-like, but it is not exactly Flux. It has actions, action creators, a store, and action objects that are used to change state. Redux simplifies the concepts of Flux a bit by removing the dispatcher and representing a full cation state with a single immutable object. Redux also introduces reducers, which are not a part of the Flux pattern. Reducers are pure functions that return a new state based on the current state and an action. State, action equals, new state. 2 Redux docs, 3 principles. State. The idea of storing state in one place isn't so crazy. In fact, we did it in the last chap. We stored it in the root of our application. In pure React or Flux apps, storing state in as few objects as possible is recommended. In Redux, it's a rule. 2. When you hear that you have to store state in one place, it might seem like an unreal solvable requirement, especially when you have different types of data. Let's consider how this can be achieved with an application that has many different types of data. Well, look at a social media app that has state spread out across different components. Figure 8:1. The app itself has user state. All of the messages are stored in state under that. Each message has its own state, and all of the posts are stored under the posts component. Figure 8:1. React app where components hold their own state. An app structured like this may work well, but as it grows it may be hard to determine the overall state of the application. It may also become cumbersome to understand where updates are coming from, considering that each component will mutate its own state with internal set state calls. What messages are expanded? What posts have been read? In order to figure out these details, we must dive into the component tree and track down the state inside of individual components. Redux simplifies the way we view state in our application by requiring us to store all state data in a single object. Everything we need to know about the application is in one place, a single source of truth. We could construct the same application with Redux by moving all of the state data into a single location. See Figure 8:2. Figure 8:2. Redux requires that we store all state in a single immutable object. In the social media app, we could see that we are managing the state of the current user, messages, and posts from the same object, the Redux store. His object even stores information about the message that is being edited, which messages are expanded, and which posts have been seen. His information is captured in arrays containing IDs that reference specific records. A. LL of the messages and posts are cached in this state object, so that data is there. With Redux, we pull state management away from React entirely. Redux will manage the state. In Figure 8.2.3, we can see the state tree for the social media app. In it, we have the messages in an array. T. Same is true for the posts. Everything we need is rooted in one object, the state tree. Each key in this single object represents a branch of the state tree. Figure 8.2.3. SAP. Simple state tree. When building Redux apps, the first thing you need to think about is state. TR. Why to define it in a single object? It is usually a good idea to draft a JSON sample of your state tree with some placeholder data. Let's go back to our color organizer application. In this application, we'll have info. Information about each color stored in an array, and information about how the colors should be sorted. A sample of our state data would look like example 8.1. Example 8.1. Code. Law organizer sample application state. Colors. ID 8658C1D09E4A9095E18001E86036. Title Ocean Blue. Color 0070FF. Rating 3. Timestamps at the 12th of March 2016 161,209 GMT 0800 PST. IDF 9005B4E9753DA64679DF172E1DBB. Title Tomato. Color D10012. Rating 2. Timestamp Friday the 11th of March 2016 120,000 GMT 0800 PST. 3 Redux Docs. Actions. ID 58D9C6864D7B9984655B145031979. Title Lawn. Color 67BF4F. Rating 1. Timestamp through the 10th of March 2016 011112 GMT 0800 PST. IDA 5685C3963DC4727918886C9A00BF7F95. Title Party Pink. Color FF00F7. Rating 5. Timestamp with the 9th of March 2016 032600 GMT 0800 PST. Sorted by date. Now that we have identified the basic structure of our application state, let's see how we update and change this state via actions. Actions. In the last section, we introduced an important Redux rule: application state should be stored in a single immutable object. Immutable means this state object doesn't change. We will eventually update this state object by replacing it entirely. In order to do this, we will need instructions about what changes. That's what actions provide. Instructions about what should change in the application state along with the misses. 3 data to make those changes. 3. Actions are the only way to update the state of a Redux application. Actions provide us with instructions about what should change, but we can also look at them like receipts about the history of what has changed over time. If users were to remove 3 colors, add 4 colors, and then rate 5 colors, they would leave a trail of information, as shown in Figure 8.4. Figure 8.4. Actions being logged to the console if they are dispatched. Usually, when we sit down to construct an object-oriented application, we start by identifying the objects, their properties, and how they work together. Your thinking, in this case, is noun-oriented. When building a Redux application, we want to shift our thinking into being verb-oriented. H. How will the actions affect the state data? Once you identify the actions, you can list them in a file called constants.js example 822. Example 822. Code. Instance listed in /constants.js. Constants equals sort colors, add color, rate color, remove color. Export default constants. In the case of the color organizer, users will need to be able to add a color, rate a color, remove a color, or sort the color list. Here, we have defined a string value for each of these action types. An action is a JavaScript object that has at minimum a field for type. Type add color. The action type is a string that defines what should happen. Add color is the action that will add a new color to our list of colors in the application state. It is pretty easy to make typos when creating actions using strings. Type add cooler. This typo would cause a bug in our application. This type of error usually does not trigger any warnings. You simply will not see the expected change of your state data. If you make these errors, they can be tough to find. This is where constants can save you. Import C from /constants. Type C.addColor. This specifies the same action, but with a JavaScript constant instead of a string. A typo in a JavaScript variable will cause the browser to throw an error. Defining actions as constants also lets you tap into the benefits of IntelliSense and Code.com. Completion in your ID. When you type the first letter or two of a constant, the ID will auto-complete it for you. Using constants is not required, but it is not a bad idea to get into the habit of incorporating them. Action type naming conventions. Action types, like add color or rate color, are just strings, so technically you could call an action anything. Typically, action types are capitalized and use underscores instead of spaces. You should also aim to clearly state the action's intended purpose. Action payload data. Actions are JavaScript literals that provide the instructions necessary to make a state change. Most state changes also require some data. Which record should I remove? What new information should I provide in a new record? We refer to this data as the action's payload. For example, when we dispatch an action like rate color, we will need to know what color to rate and what rating to apply to that color. This information can be passed directly with the action in the same Java script literal. See example 823. Example 823. Rate color action. Type rate color, ID 5685C396BDC 4727918886C9A00BF7F95. For Redux docs, reducers. Rating 4. Example 823 contains the action type, rate color, and the data necessary to change the specified color's rating to 4. When we add new colors, we will need details about the color to add. Example 824. Example 824. AD. Color action. Type add color, color FFFFFF. Title bright white, Rating 0. ID B5685C393BDC 4727918886C9833DF7F52. Timestamps at the 12th of March 2016 161,209 GMT 0800 PST. This action tells Redux to add a new color called bright white to the state. L of the information for the new color is included in the action. Actions are nice little pack. Ages that tell Redux how state should be changed. Th. It also include any associated data that Redux will need to make the change. Reduces our entire state tree is stored in a single object. A potential complaint might be that it's not modular enough, possibly because you're considering modularity as discrete. In objects. Redux achieves modularity via functions. Functions are used to update parts of the state tree. Th. These functions are called reducers. For reducers are functions that take the current state along with an action as arguments and use them to create and return a new state. Reducers are designed to update specific parts of the state tree, either leaves or branches. We can then compose reducers into one reducer that can handle updating the entire state of our app given any action. The color organizer stores all of the state data in a single tree. See example 8-5. If we want to use Redux for this app, we can create several reducers that each target specific leaves and branches on our state tree. Example 8-5. Code. Law organizer sample application state. Colors. ID 8658C1D09E4A9095E18001E86036. Title Ocean Blue. Color 0070FF. Rating 3. Timestamps at the 12th of March 2016 161,209 GMT 0800 PST. IDF 9005B4E9753D64679DF172E1DBV. Title Tomato. Color D10012. Rating 2. Timestamp Friday the 11th of March 2016 120,000 GMT 0800 PST. ID 58D9C6864D7B9984655B145031979. Title Lawn. Color 67BF4F. Rating 1. Timestamp due the 10th of March 2016 011112 GMT 0800 PST. ID 5685C396BDC4727918886C9800BF7F95. Title Party Pink. Color FF00F7. Rating 5. Timestamp with the 9th of March 2016 032600 GMT 0800 PST. Sorted by date. This state data has two main branches, colors and sort. The sort branch is a leaf. It doesn't contain any child nodes. The colors branch stores multiple colors. Each color object represents a leaf. Figure 8-5. Figure 8-5. Color organizer state tree. A separate reducer will be used to handle each part of this state tree. Each reducer is simply a function, so we can stub them all at once with the code in example 8-6. Example 8-6. C. Layer organizer stubbed reducers. Import C from /constants. Export const color equals state equals action equals return. Export const colors equals state equals action equals return. Export const sort equals state equals sorted by date action equals return. Notice that the color reducer expects state to be an object and returns an object. T. He colors reducer takes in state as an array and returns an array. The sort reducer takes in a string and returns a string. E. A function is focused on a specific part of our state tree. The returned value and initial state for each function correspond to their data type in the state tree. C. Layers are being stored in an array. Each color is an object. The sort property is a string. Each reducer is designed to handle only the actions necessary to update its part of the state tree. T. The color reducer will handle only actions that require a new or changed color object at color and rate color. T. The colors reducer will focus on those actions necessary for managing the colors array at color, remove color, rate color. F. Initially, the sort reducer will handle the sort colors action. Each reducer is composed or combined into a single reducer function that will use the store. T. The colors reducer is composed with the color reducer to manage individual colors within the array. T. The sort reducer will then be combined with the colors reducer to create a single reducer function. T. His can update our entire state tree and handle any action sent to it. See Figure 8-6. Figure 8-6. Color organizer reducer tree. Both the colors and color reducers will handle add color and rate color. But remember, each reducer focuses on a specific part of the state tree. Rate color in the color reducer will handle the task of changing an individual color's rating value. Rate color in the colors reducer will focus on locating the color that needs to be rated in the array. Add color in the color reducer will result in a new color object with the correct properties. Add color in the colors reducer will return an array that has an additional color object. They are meant to work together. Each reducer focuses on what a specific action means for its branch in the state tree. Reducer composition is not required, just recommended. Redux does not require that we create smaller, more focused reducers and compose them into a single reducer. We could create one reducer function to handle every action in our app. In doing so, we would lose the benefits of modularity and functional programming. The color reducers can be coded in a number of different ways. Switch statements are a popular choice because they can process the different types of actions that reducers must have. DLE. The color reducer tests the action type in a switch statement and then handles each action type with a switch case. Export const color equals state equals action equals switch action type kc.add color return id action.id title action.title color action.color timestamp action.timestamp rating 0 kc.rate color return state.id equals action.id state rating action.rating default return state. Here are the actions for the color reducer. Add color returns a new color object constructed from the action's payload data. Rate color returns a new color object with the desired rating. The S7 object spread opera. Tor allows us to assign the value of the current state to a new object. Reducers should always return something. If for some reason this reducer is invoked with an unrecognized action, we will return the current state, the default case. Now that we have a color reducer, we can use it to return new colors or rate existing colors. For example, / adding a new color. Const action equals type add color, ID 42431P098049005P48001LHYF3036. Color 0000FF. Title Big Blue. Timestamp through the 10th of March, 2016 011112 GMT 0800 PST. Console.log color, action. / console output. / ID 42431P098049095P48001LHYF3036. / color 0000FF. / title Big Blue. / timestamp through the 10th of March, 2016 011112 GMT 0800 PST. / rating 0. / The new color object is returned with all fields represented, including the default rat. In of 0. To change an existing color, we can send the rate color action with the ID and new rating. Const existing color equals ID 1281P53800E5233P08401LHYF3036. Title Big Blue. Color 0000FF. Timestamp through the 10th of March, 2016 011112 GMT 0800 PST. Rating 0. Const action equals type rate color, ID 42431P098049095P48001LHYF3036. Rating 4. Console.log color existing color, action. / console output. / ID 42431P098049095P48001LHYF3036. / title Big Blue. / color 0000FF. / timestamp through the 10th of March, 2016 011112 GMT 0800 PST. / rating 4. / The color reducer is a function that creates a new object or rates an existing one. You'll notice that the rate color action passes an ID that's not used by the color reducer. That's because the ID of this action is used to locate the color in an entirely different reducer. One action object can impact several reducers. The colors reducer. The color reducer is designed to manage leaves on the colors branch of our state tree. The colors reducer will be used to manage the entire colors branch. Export const colors equals state equals action equals switch action dot type kc dot add color return state color action kc dot rate color Return state.map. C equals color action. KC.remove color. Return state.filter. C equals C.id equals action.id. Default. Return state. The colors reducer will handle any actions for adding, rating, and removing colors. Add color creates a new array by concatenating all of the values of the existing state array with a new color object. The new color is created by passing a blank state object and the action to the color reducer. Rate color returns a new array of colors with the desired color rated. The colors reducer locates the color to be rated within the current state array. It then uses the color reducer to obtain the newly rated color object and replaces it in the array. Remove color creates a new array by filtering out the desired color to remove. The colors reducer is concerned with the array of colors. It uses the color reducer to focus on the individual color objects. Treat state as an immutable object in all of these reducers. We need to treat state as an immutable object. Although it may be tempting to use state.put or state_index.rating, we should resist the urge to do so. Now colors can be added, rated, or removed from the colors array with this pure function. Const current colors equals ID 9813E2P43802E4495P48001L8YF3036. Title berry blue. Color 000066. Rating 0. Timestamp through the 10th of March 2016 011112 GMT 0800 PST. Const action equals type add color ID 55237P3AB21E3595P48001L8YF3036. Title party pink. Color F142FF. Timestamp through the 10th of March 2016 011112 GMT 0800 PST. Console.log colors current colors action / console output / ID 9813E2P43802E44995P48001L8YF3036 / title berry blue / color 000066 / timestamp through the 10th of March 2016 011112 GMT 0800 PST / rating 0 / ID 55237P3AB21E3595P48001L8YF3036 / title party pink / color F142FF / timestamp through the 10th of March 2016 011112 GMT 0800 PST / rating 0 / no side effects in reducers. Reducers should be predictable. They are used to simply manage the state data. In the previous example, notice that the timestamp and IDs are generated prior to sending the action to the reducer. Generating random data, calling APIs, and other asynchronous processes should be handled outside of reducers. Avoiding state mutations and side effects is always recommended. We can also remove a color from state or rate an individual color in state by sending the appropriate action to the colors reducer. The sort reducer. The sort reducer is an entire function designed to manage one string variable in our state. Export const sort equals state equals sorted by date, action equals switch action dot type kc dot sort colors return action dot sort by default return state. The sort reducer is used to change the sort state variable. It sets the sort state to the value of the action sort by field. If this is not a state provided, it will return sorted by date. Const state equals sorted by date. Const action equals type c dot sort colors, sort by sorted the title. Console.log sort state, action // sorted the title. To recap, state updates are handled by reducers. Reducers are pure functions that take in state as the first argument and an action as the second argument. Reducers do not cause side effects and should treat their arguments as immutable data. In Redux 5 Redux docs, store. Modularity is achieved through reducers. Eventually, reducers are combined into a single reducer, a function that can update the entire state tree. In this section, we saw how reducers can be composed. We saw how the colors reducer uses the color reducer to assist in color management. In the next section, we will look at how the colors reducer can be combined with the sort reducer to update state. The store in Redux. The store is what holds the application's state data and handles all